My name is Andy Shevchenko. I will tell you about my experience with reviewing Linux kernel code in this presentation. So let's start. Unfortunately, this remote doesn't work, so I need to press something on keyboard. Yeah. So here is some kind of brag sheet, but basically I do a lot of review, I do a lot of contribution, and I do maintain something. Before I start my presentation, I would like to cite Torvalds from 2005, by the way. That's most important here is drivers really are the bulk of the kernel, and drivers often have the lowest quality of code. This is basically what my presentation is targeting, about quality of the driver's code and what I'm doing mostly. It's not many chapters, but each chapter has something to tell you. So let's start from recapturing of 10 years of Linux kernel. What happened was 10 years. I need to tell you that this presentation first was given 10 years, almost 10 years ago, and at least one guy in this audience heard it in person. Yeah, so now it's a refurbished version. For these 10 years, you can see that Linux kernel is still growing, the code is growing. We have still the same almost amount of active contributors. It's about 2,000 nowadays, not much more than previously. Almost the same amount of change sets, but the code is growing and growing. Independently on what we removed. We removed lately a lot of architecture. We removed a lot of stale drivers, old drivers code. But you see, the problem is that it's like an avalanche. We still get more and more. That's why reviewing code is really important. First, to capture, I would like to tell about pointer extension. It's an interesting invention in Linux kernel to the %p specifier, format specifier, to the printf basically. Clever idea to get something custom without getting a compiler warnings, because compiler usually check the specifier, format specifier, and if they find something different from the standard of POSIX, then they tell, we don't know how to parse it, something wrong with your format string. And clever idea here is, okay, let's use %p as print and pointer, but since we control what is in format string, we parse format string ourselves, we could parse something after that. And we could add more characters like digits and usually letters. And we could extend basically infinitely whatever we want and customize whatever we want. That is the idea behind pointer extension, and it's used a lot, of course, in the kernel. And now let's see how much it's used. Here is the pointer extensions. It's actually first page only, which were present already 10 years ago. And this you could see statistics, what happened within 10 years. I took LTS kernels just like to be like on the edge of the year, so for better measurement. And you see some of pointers are growing, some of pointers are growing really fast, depending, of course it's not appear at all, those pointer extensions not appear in the same version of kernel. That's why you could see different numbers. It's not only because somebody used more or less them, or because drivers use them more or less, new drivers. Then, again, it's continuation. So altogether, it's 16 pointer extensions were in 4.9, 10 years ago. Yeah, and in 6.18, you see a lot of growing of users. Now, the next page is what is new, what came during the 10 years. You see, it's not like stable thing. People would like to print more stuff in unified format. Yeah, basically, of course, it was time when device 3 was developed a lot, and device 3 open firmware support was developed a lot, and they need to print it. They invented also their own specifier. About 5 to 6 years ago, there is also introduced this firmware node. It's agnostic approach because there are ACPI-based system, OF-based system, some other systems, and they could use the same specifier and specific data type in the kernel to print all that information about device 3 node or firmware node. Of course, there is a new thing, it's error pointers, because we use another interesting trick in Linux kernel is when you would like, when your function is returning data type, like pointer to the structure, like allocator or something, and you would like to return not only null, but the reason why you cannot allocate. And clever idea was that, okay, let's reserve the last page of the address space for so-called error pointers. It's not a real page. You cannot put any memory or use it, but it uses as error pointer. So when we get the value, it's up to 4095, at the last page, so either on 32 bits or 64 bits, the last one, then it means it's some error happened, and we could convert that very easily just by casting to negative number, and we get error. That's it. So error pointer here is printing specifier to human readable format. When you see not just code like -22, who remembers what is -22? Yeah, it prints like E, no E inval or E something. And people at least understand more context of what the heck is going on there. Also, 4CC is standard coding in 32-bit value, basically a number. It's like 4 ASCII letters or something which you could print. And it's used, it's basically two steps. First, it's Video for Linux, which brought it in. And then some people would like to use it in more generic way. So they extended it. No, then time and date. It appears that for many years, nobody cares how we print time and date in DMASC or in the sysfs. Luckily, most of the users do this in a correct way. I mean, where it's sysfs, where it's ABI. Where it's debug printing, it was tons different formats, how we print. First year, first month, first day of the month, then time with colon, with dash, with dot, with, I don't know. Now we have at least standard way how we print time and date from the RTC, struct RTC time, or from time spec 64. That basically supported currently. I never heard before creating this presentation, okay, not never heard, maybe never paid attention, about point differences. I don't know who using them. No idea. Rust, yes, they have some special specifier to like proxying, basically. They provide format strings themselves, and they proxy to the kernel library code. And they have this special specifier which must be used only in Rust code and Rust glue code. I'm not Rust expert, so I don't know about that. And then a new thing also, it's struct range. Whatever you could check, it just basically a struct of two 64-bit numbers, start and end, if I remember correctly, and that's it. It prints in a nice standard format. So that's what happened there, and very useful. Please use it in your drivers. Do not reinvent the wheel. Next chapter is about managed resources. Managed resources, the idea came in 2007, if I remember correctly. The idea is that, okay, we would like to garbage collect the resources we allocate at the prop stage when we bind the device to the driver. And we would like to release them in the remove stage in the proper ordering, and do not leak anything. So how we do that? The idea is very simple. There is a list in the stack device, and these device managed APIs, they just put, basically allocate resource and put to that list. That is how it works. And when device is removed, the device core, driver core goes through the list and releases this, because the list also has pointers to release functions for each of that resource. So it knows how to release the resources. Of course, it used very much in the drivers. You see, I put in almost everything what was in 10 years ago in 4.9. There are some niche stuff which is absent in this list, but just to give you a picture. And on the right slide, I put what happened in the 10 years, what we get more, what some of those were, of course, in 4.9, but what grew a lot, or something interesting what you could use in the drivers. So you could see that, for example, common clock framework, it got like 20 new API calls and so on. It means that device drivers and people really want to use that techniques and use this mechanism to allocate and to make their remove function, remove callback either gone at all or be really, really small. And of course, error path and error handling in the prop function becomes like 0 in this case. So for 10 years, we have newcomers. You see a lot of
The problem is they're actually really dangerous the way people use it, because it sounds nice to tie the lifetime of your resources to the device, but for a lot of the resources, that's actually the wrong lifetime rules, because devices can't go way underneath you, and driver writers have a hard time understanding this. So these APIs actually lead to a lot of use after free and other exploitable races in terms of hot plugging. They're actually really, really dangerous, and people should not be using them most of the time.
Almost like it's a typical mistake when you're submitting code.
Yes?
Yes, and I have slides about that. You could be surprised. It's just a bit later. It's just a wrap up now. Yeah. That's true. So this, as you see, more cameras, more APIs, and you see also there is removing some APIs related to release, because people rely on the reversed order of release done by driver core. Now, as we see problems, like Christoph said, yeah. So, problematic ordering, first one, yes. When you put something in the prop function which allocated before resource which is unmanaged, and then other way around. You allocate something unmanaged before then allocating some managed resources. In error pass or in the remove, it will be different order. Sometimes it's not a problem if just it's memory allocation. Might be not a problem. Sometimes it's really big issue. And if you try just smoke test of insert driver module, remove driver module, insert driver module, remove again. Try 2 times, and believe me, 50% maybe of the kernel drivers nowadays, they just crash on that. Then less severe is duplicating messaging, error messaging, because some APIs already, it was a wave of some managed resources for IO remapping. They were printing all error codes, whatever they fail about, they print. So don't do it in your driver. The same now with new wave with devm IRQ, request threaded IRQ and so on. They also printed error message, and a lot of drivers, legacy drivers, do the same. Yeah, and now what we already heard, object lifetime problem. So we need to understand whose lifetime is last longer. If we manage, if you take managed resources, then its lifetime is binded to the device instance. Even if the same driver, you have different device instances, they have different lifetimes of maybe the same type of the object, but instances are different and their lifetime different. So, of course, ownership. If you have parent and child relationship of the device, and you, by mistake or I don't know how, in the child device, you allocate a resource which is bound to the parent device, or vice versa. Sometimes it could be visible problem immediately, because if you allocate, if you use at the parent the resource allocated by the child, of course you will see it quicker, sooner than later. But if it's other way around, usually there is a ref counting, you will never see it, but you should understand that it's still a problem. And race conditions, all type of race conditions. If you use IRQ handler, how many drivers use IRQ handlers? Maybe most of them, like 98%. Work jobs, some timer callbacks, all of them can fire at any surprising time in your removal stage. You unbind device from the driver and oops, IRQ fired. What to do if we already freed the memory which IRQ handler wants to use? Yeah. Here is one scenario basically when what could go wrong with memory allocation? Yeah. If we create a character device, and then character device uses a memory from the managed resources of real physical device driver, user space could take file, open it for IOCTL or for some other read writes. And if you keep that file opened for a long time and unbind device from the driver, oops, yeah, easily to reproduce that. And I believe we still have a lot of drivers doing like this. The question is attributes about in CSFS. Also interesting topic, because in CSFS, most used attributes when you create a device driver is either driver attributes or device attributes. With device attributes, there is no problem because the lifetime is the same as device. Yes, it could, in that callbacks, you could reuse the objects which were allocated with managed resources. But if it's driver lifetime CSFS attributes, of course you may not. You may not use a memory which device instance allocated using managed resources. So you need to be careful about it. Another scenario is what I told, and it's actually a funny thing that it was reported like months ago in the subsystem which I am maintaining. It's not my code, but yeah, I know how to solve it. I'm just lazy. It was marketed as an odd fixes in maintainer database. So anybody who has time and want to fix, please come and fix. So yeah, when we have basically problem with the ownership, the parent, not the parent, the child is using resources allocated. Yeah, allocated by parent, and parent device is disappearing. So, and user CSFS attributes. Yeah, of course, easy to reproduce. So takeaways: code grows, a lot of API appears also APIs, new APIs for managed resources. You could use them, but use with caution. If you also, I haven't taught on the slides, why release functions are gone in some APIs? Because they should not be used in many cases. When you see a release function, for example, devm k3 is used explicitly, in many cases, not exactly, but in many cases, it's a sign of something is going wrong. Either you use device managed resources just for fun when it's not needed at all, or you don't understand the object lifetime. And be careful about it. During the probe, when you have managed resources and unmanaged resources, always group them that managed resources goes first, all of them, and unmanaged goes last, all of them. So there is basically, it should not be code like devm calling something and then go to error path in the probe. If you see that, it's immediately, it's something wrong. If you want your driver to be remove function clean, like you could completely remove function in your driver. To do that, you need to put all allocation, all resources into manager, to be managed. Some of the APIs does not provide that. To have that be managed, we have a couple of wrappers, and you could, basically using those wrappers, you could customize in your driver, provide a release function, and do like mimic like it was a managed resources. And yeah, always pay attention in the hardware, how hardware works, when it could fire IRQ, or when timer or software job could fire, could be scheduled, because it could, during removal stage, it could be surprise for you. And it's really hard to hunt these bugs. Sometimes they appear, sometimes it's not, because it's race condition bugs. Next small chapter is about resource acquisition is initialization. Also for helping for garbage collecting. It's more modern technique. In Linux kernel, it's modern. It's existing in compiler for more than 20 years. It's like 3 years old. Peter Z provided a cleanup.h header and provided a few macros, useful macros. Basically, in the driver, you mostly use this guard and scoped guard for locking. Rarely, this define kafree, which defines a cleanup function. Basically, you can have some allocator, and then you define this cleanup function, and you tell, okay, this allocated resource should be cleaned out of the scope using this cleanup function. So this helps to avoid all those missing locks or dead locks or some problems with forgetting unlock, forgetting lock, doing it twice or doing in some different ordering. The guard is using existing scope, and here is, of course, typical mistake people do even when converting some drivers. Some newcomers trying to convert some drivers instead of using explicit lock, unlock to guard semantics. They use goto. It cannot work because basically when you use guard, compiler automatically provides a cleanup function even if you never go to that code. For example, it's easy example is just function with the two calls. Go to label, which returns something, and guard of some variable where the function, let's say, prints something, not lock, unlock, but prints something. And you will see printing, even if it's go to already before in the C code. It surprises many people, but that is the thing. Never use go-to with guard mnemonics. Refactor your code or do something, but never do go-to. Scope guard is exactly for that. It's like do-while approach, do-while zero, like one time loop. And there you could put your code, and then after that you could, of course, go to or something. But you could do something small in your critical section, and that's it. Now the interesting chapter. What I learned for 10 years. So how the typical mistakes changed. Basically, this is a collection of what I noticed last years, not before. Yeah. New generation. They would like to reply to use the tools, whatever provided now, not email properly. They have Outlook, they reply in Outlook. Yeah, we have top posting. They would like to fix the issue very fast and tell everybody that, oh, I fixed it in 2 hours. Yeah, they send the version just within a couple of hours. Then another version, then another. At the same day, maintainer, so they are, for example, located in Europe. Maintainer wakes up in the US, 12 versions of patch. Yeah, very nice. Yeah, then of course they are using, oh, I'm a clever guy. I know that maintainer maybe will be lost. Let's help maintainer. Let's reply to the same email thread with all 12 versions of the patch. Maintainer, where is the patch I need to review? Who's those guys to reply to that already? Yeah, so of course then they do a lot of them now with you know what help. They do a lot of stuff. They are so productive now, and they often do the double effort. So we got for Atom ISP, we got maybe about 10 or more patches from 10 or more different people for the very same thing. Same file and same patch looking. It's, yeah, interesting. Interesting. They really don't want to read anything. They just want, let's do it. Yeah. And yeah, basically, the real problem here, those problems more about process. The real problem is that often they do reinventing the wheel of APIs because they use help or assistance or something, and they, I know how to implement, for example, strlen in C code, just with a while loop. Yeah, let's put it. And then, yeah, we get like 100 lines of code more in the driver, which should be 50 lines of code only. Because somebody decided not to use kernel APIs, which exist, or helpers. And to be honest, I understand them. It's really hard. There is no book of, okay, I open the book, version kernel 6.18. This is API, and that's like encyclopedia. There is no encyclopedia in the kernel. They need to ask, the rule of thumb here basically, if you see something which you feel like it has to be already implemented, like, I don't know, CRC8 algorithm. Yeah, it feels like it's so old, it should be implemented. Yeah, try to find it. Try first to find it before implementing yourself, because it's simple algorithm. You could implement it with, I don't know, half an hour, maybe with all test cases even. But yeah. Then another problem with kernel headers. Most of the patches I got now is in IIO subsystem. And IIO subsystem decided that we are going to be more strict about headers. So we follow this include what you use principle. It means that basically if header A includes header B, and your code includes header A and uses something, some APIs or constant from header B, it also must include header B, not only header A. But without fanatism. Because, yeah, if you go with that tool, it will tell you, like, include some ASM or something for something. You really don't want to do that. So use a common sense and use some customizers configuration. You could ask Jonathan Cameron, who created a custom config, and it's closest what we have now to the kernel, but it's still far, far away from ideal, what it should be. That is the only tool what we have. And we have also some people, I won't point finger on myself, who knows by heart a lot of headers and dependencies. So what should be included, what should not be included. It's just by experience, but I did it 10 years of review, you could imagine. I remember a lot about that. Yeah, here, two examples of the, like, include everything headers. Device.h, in many, many drivers, we don't need device.h, which includes everything, basically, entire world. We need only, like, to print something, we use dev error probe, or we use dev something, and we might use dev mkmalloc, which is in device devres.h. New header appeared like last year, I believe. I don't remember. I created that header, but I don't remember. So don't use that, and never, ever, almost, use kernel.h. It's a mess. It's a train wreck header. It should not be used in the drivers. It's split already to many, many other headers, and basically what is left in kernel.h should not be used in the drivers. It's only rare, some exceptional code, but not regular driver. Also often from the examples over internet, from the past, I don't know, from the colleagues, it's like cargo cult. People are using of.h for including ID tables definitions. The proper header is mod device table.h. Use that header. Then also for device properties in IIO, we don't accept, with rare exceptions in some cases, but really exceptional cases, we don't accept code which includes of.h. So if you use ARM board, you create a driver, yeah, I'm using device tree. Everybody uses device tree. Not everybody, first of all. And we would like to have drivers clean from the platform data. So some code might use platform data, which is called now software nodes, and uses the same, basically, provider uses the same mechanism, and driver just use one API call for reading that property. And you don't care about what is behind that. ACPI, OF, software node, whatever else in the future. So don't basically use that or try to avoid. It helps also in ACPI-based system, we could reuse without ACPI identifiers. We could use OF in the identifiers, compatible strings. Not many people know that. The driver could be reused without recompiling or anything. I have not so much time, so I need to speed up. So, compilation problems. Nowadays, for 10 years, we got a C1 as a first-class citizen. So basically, if you compile code, compile with C1. Also, most of CIs and many maintainers require first level of warnings to be clean, build clean of those warnings. So compile with W equal 1 and compile by C1 and GCC. Why? Because on the first level of warnings, they have different subset of those warnings enabled, and you could see different warnings depending on different version of compilers as well. It's interesting. So you need to compile both to see in both cases that first level warnings are not there. Use static analyzers. Many of you probably heard of sparse, and kernel has integration with sparse, so use that. Check also in IIO subsystem, we have a lot of drivers that I use protocols, and protocols are with fixed endianness that often not host endianness. Of course, we need to do conversion, use the specific types, and sparse has some checker for that. So when you use a code, when you use, for example, variable not annotated as a special type, special endianness, and then you use as a normal CPU type, like native endianness, and sparse warns about that. So altogether, this is the last line, start your make like with this. It's basically almost my daily basis make command for Linux kernel. Also pay attention when you do some data structures, pay attention on their layout and ordering. Layout, we have a nice tool, PAHole. I don't remember how this acronym, what it states for, but whole for whole, but PA, I don't remember. So it finds the gaps in your data structures, and if there is some gaps which could be filled, it even could recommend, oh, you see like 3 bytes gap in your data structure, and then at the end, for example, you have a 1 Boolean variable. Then you move just that Boolean variable, you have plus 4 bytes for somebody else. So free memory for everybody. Yeah, so use that tool, and in conjunction with the tool, it's always interesting to use blow autometer. It's a script from Linux kernel source 3. It shows you size of the object. For example, very interesting example is when you have some data structure, and this data structure is basically an item, an entry in a list. You put a struct list head, like head there, or list, and put some weight. Yeah, it has like 8 bytes per pointer in 64-bit or 4 bytes in 32-bit architecture. Okay, when you shuffle, it doesn't mean anything because it's aligned. So that doesn't change anything. But if you put it the first in the data structure, the container of in all list APIs become a no-op, because your head is basically immediately goes. It's the same as a data structure pointer to the data structure is the same as a pointer to the list. So the container of doesn't do anything. At compile time, you already gone from few bytes of code for free. Again, so use that 2 tools. They are very useful. Okay, I skip this because no time. You could read. It's some stuff. Takeaways. So read and study documentation. Yeah, process is important. Even if you do your first, don't do fast. Take your time, read documentation. Become familiar with existing APIs. Yeah, like I said, there is no encyclopedia. There is no encyclopedia. Unfortunately, you could easily reinvent a view. There are so many macros helpers for like a Swiss knife on steroids. But you need to get familiar with that. How to do that? Start reviewing first. Start reviewing. Help maintainers review other code. You will learn from that. Maybe you don't understand that code. Try to understand the code. You spend some time, you spend week, you spend couple of weeks on mailing list. You become familiar, you will understand much better, believe me, how in this subsystem your code should look like. Use existing tools. Of course, we have some for mailing list that will make your patch looking nice, and all maintainers will be happy with that. Compile your code with clang, with GCC, and compile with warning level equal 1 at least. You could, of course, enable 2, but it'd be a headache to fix all that crap there. Now, the third most interesting part. New this year, basically, and headache for maintainers. Yeah, AI-assisted contribution. We have got a lot in IO subsystem, you could imagine. Yeah, luckily, Google provided a new bot, Sashiko, which does a review in the many stages. It's now its current state. It started from 6th stage or something. Now they have this list. I updated it recently. So you see, it does a lot of things. Probably works nicely. Let's see. My first Sashiko review. So I sent a patch in March this year. Simple patch. You could see the code. Yeah, what Sashiko does. Yeah, it tells me something going wrong, but not with my code. It was there already before my code. Some problem. Yeah, nice, it found, I'm impressed. Second, It doesn't found any problem with my code, which immediately Linux kernel project that zero-day CI found immediately. Because some compiler, GCC compiler, on first level of warnings, complains that, maybe you two strings of the same length cannot fit the same length at the end. Yeah, it's initial code, it's the same code. I didn't change functionality of that, but I got a new compiler warning. Not good. So let's see, I sent a new version. Again, now it's much better. It explains me where is the problem. But again, it's not my problem. Thank you, Sashiko, thank you. Somebody else maybe could fix it. Wow. It was about 20th of March. I found in the Git history that 3rd of March, it was a patch which fixes exactly that problem. Yeah, so now I got, it's not my patch, I got a patch against driver I am maintaining. Yeah, the commit message like Dostoevsky novel. Yeah. Very nice because it's probably AI generated. I don't know. I believe it's AI generated. I don't know. Because I saw the Sashiko report on this. It looks similar, but it's not the same. First of all, yeah, it explains me what the code is. Thank you. That there are two excerpts of the code which I see. It's not a rocket science code. It's nothing really problematic to understand reading that code in the code. No need to put it in the commit message. Why is it there? I don't know. It doesn't state why we do that. Yeah, it's something about KM-SUN, OOP-SUN, C standard, undefined behavior, but why? What exactly? What exactly is a real-life problem? There is no evidence of real-life problem. So, and from software aspect, if you look at the code, yeah, it calculates this pointer. It calculates it based on the capability of set, which is garbage, basically. It's something on the stack, which was never initialized. Okay, fine, I calculate, but I never used it. I have checks there. From the style point of view, it's a bad code. From functional point of view, there is nothing wrong with that code. It's not used. So compiler, most likely with optimization on, which is default in the kernel, compiler just will not calculate that before checking the flags. Why it should calculate? Oh, and of course, it misses completely the hardware, how hardware works. So those capabilities, it's not shown. It's not shown in that excerpt, by the way. That this capability feature, it's assigned exactly before capability offset. So capability feature will not be set in the cases when it's garbage, because it's hardware. The question, what it complains about, it just doesn't understand how hardware works. But if hardware doesn't work, we have much more bigger problems than this some pointer initialization. We have broken hardware. So, and proposed solution, I don't know, guy who sent it, I don't know if it's himself or if it was also AI assisted, at least was no tag. Proposed solution is to hide the problem. Just, okay, let's make this capability of set comes from the array on the stack. Let's just nullify that array. Yeah, but it doesn't fix the problem, real problem. It just hides it. Yeah, it's a compiler, nobody will complain about it, but there is still problem of the pre-calculation of something with just 0 instead of garbage, but it's still wrong. 0 may be used in the wrong context. So, third version of the patch, you see commit message. Nice. Yeah, we almost shortened to the point. The problem is it still doesn't explain why, but I already gave up on this. I thought, okay, I accept it. I understand the code. It's not a rocket science. It's really small change. Okay, let's accept it. And it's fixed exactly reported issue. So it's moved that basically decoupled assignment and definition. Now in new code, you see void IOM base, semicolon, and then after this check, it's base equal blah, blah, blah. So when it's exactly used. So now code looks nice, everybody is happy. So statistics, my personal statistics. Up to date, Sashika reviewed 61 of my contribution. So yeah, valid reports, 14, it's about how many? 25%. Yeah, good job. It's helpful. I agree. Then it gives like 4 nice comments. And nowadays they change it, of course, they changed some text in their wording. Now it starts even. It's not a bug, but blah, 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 and then Dostoevsky novel. Yeah, you could skip it, of course. And yeah, 4, it's like 6% of that. Then this nice, yeah, I found something. Yeah, but it was before your code, and it is after your code. So congratulations, Sashika. You find a problem, but it's not in my code. And my code doesn't affect or be affected by that. So why should I care? And some really misses is like some guesswork, some hallucinations. Hallucination was really nice. It was a documentation fix in some driver core commands. It comments, it's not code, it comments. In first patch, it found something, and it found the word in English which I presumably used, which was not there. So it hallucinated a word I used and suggested me to do something about that word. Yeah, but I never used that word. In second version of the same patch, it just tell all green. What was that? Nobody knows. So that is basically statistics of AI. Yeah, then recently I got another patch series. Somebody decided to quickly get something for Linux kernel and created a 12 patches, series of 12 patches. Really nice. Nice job, and some started, only what was probably a bit human written is cover letter. All messages were like without anything except assisted by and signed off by tags, so no commit messages at all. Just subject line and 2 tags. We never accept that for, I don't know, last 10 years, such contributions. We are not anymore in 2007. So I just put here first 4 patches because it's like patch series of 3 patch series inside. And first patch series seems like the most important, like bug fixes or something. Yeah, let's check. First, style adjustments. Is it bug fix? Why do we need that? Okay, maybe in some cases, but not as a standalone. Modernized parsing in quirks. Yeah, I haven't put a code, I just explain you quickly. We have string functions to parse string to numbers in strings. One call it simple str to something, and the other group of functions call it k-str to something, to int, to u8, to blah, blah, blah. So basically, simple str could parse constant string in place. It doesn't really require that some string end exactly when the number ends, and everything, all those rules. KSTR2 is a strict version. It requires string to be null terminated, to be only number, blah, 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 and overflow, and all those stuff, all checks. So we use the simplest R to whatever. In the code, in the case, we exactly know that it never goes differently because it's a string comes from the ACPI done by ACPI specification. It could not be wrong anyhow. Even if it's malicious ACPI ML code, you cannot really provide anything wrong there. It's impossible because there are not enough bytes for that in ACPI. Interpreter will break if something wrong. So modernization is just uglifying the code. It was one function, simple str to something. Now it's creating a buffer, copying substring to the buffer, using kstr to something, checking that result, then using that result. Yeah, plus 20 lines of code for I don't know what. Then added robust bound checking for ACPI GPI resources pin ranges. Yeah, nice code. Found two cases. In one case, it might be interesting, but might be not. In second case, it's completely out because there is he put it, or it puts a check for the value not be bigger than something like 255 or something. I don't remember right now. And the follow-up line, even in the patch, it was visible. The follow-up line is a for loop which uses exactly the same condition inside. So it was just a dead code. Dead check, not dead code, but it's like switches from what for loop does, we duplicate before for loop. And then 8 patches, like just for fun, modernizing, no explanation why he's doing, because he knows how AI works now. I don't know. So takeaways, yeah, I'm honestly impressed about Sashika. I like it. It's helpful. But you have to use common sense when reading and when check it. So that's why it's with caveats. So grain of salt and check with somebody maybe. Also follow the process. Process is important independently. AI generated, you written the code, your neighbor, whoever. Also, the idea is that if it's an AI-assisted material, contributor should be prepared for explaining everything. If contributor doesn't know what he or she is doing, then what's the point? This contribution meaningless, because then who should explain what is doing and what it does? Yeah, and of course, yeah, like I said, human interaction is still needed. And sometimes AI is exhausting maintainers and capacity of maintainers. So maybe in the future it will be better. I don't know. Let's see. Thank you. Sorry, we have not much time for questions, but I believe still.
Just a few quick questions.
So you have a lot of really valuable information in this talk. Did you consider making a patch for the Shevchenko prompts? Because then you will actually help making it more precise, right? It's on GitHub. You can mail them the patches for.
Yeah. I should have started my presentation that first time when I gave it in 2017. It was exactly the question from audience. Okay, what are you going to do if AI substitutes you? Now it's the time when AI substitutes me. I am very happy with that. I am really honestly happy that somebody will do my job. Yeah, about prompt. Actually, yeah, recent days I saw a colleague of mine who created like preview prompt before he even looked in the patch. He is a maintainer also of some subsystems in kernel. And yeah, I was thinking exactly like you said about creating my prompts because they are different. I saw his, like really we could be like in joint force. He's about something more architectural, more like deep core thing, and mine more about drivers and stuff. So
Yeah, I know
yeah.
at least for the Rust subsystem. So in Sashiko they have per subsystem prompts. So for the Rust one, we added, instructions for catching. Like you have lots of common pitfalls here, right? We added that to the Sashiko. So now all the new people submitting the Rust patches, they will automatically get the,
Yeah, or
default
at least could be used with the local instances of Sashiko, yeah.
Did these prompts help?
Yes, they are valuable.
I think we have one more question. Time for one more? No? So then, thank you very much.
Thank you.